Hello, everybody. Again, as Bill said, my name is John Pratten. I'm with Proactive Maintenance, a company I started last year, May 1st. I'd like to welcome you all. This presentation will just cover some of the real basics of thermography, mostly associated with the building envelope area, although I do touch on some of the other technologies that infrared can cover for you as your knowledge and need for infrared increases. So let's just get started with what we're going to cover today as far as an agenda. I'm just going to get into just a little bit of the history. Sometimes knowing where you're going, it's always nice to know where the technology came from. It's kind of interesting. We'll just get into a little bit of thermal imaging and where it's used. And then I'm just going to talk about some thermal considerations, things to think about while you're getting ready to do infrared, setting up programs, etc. And then just some common inspection scenarios, different areas where infrared is used, and we'll be discussing some key points with those. And of course, a little area on just choosing a thermal imager. Some of you may be joining us today and you don't have an imager yet, but there's things to think about. And we'll just talk about a few of those briefly. And then, of course, at the end, just a quick wrap-up summary, and Bill will make a few closing comments as well. So, an effective infrared scanning program, I kind of coined it with being analogous to a three-legged stool. You need to know your camera. You need to know it fairly well. You need to understand the science of infrared. Knowing a little bit about thermography is going to be key to being successful. And of course, whether you're doing home inspections or you're doing a process, have a complete system set up at your place of business, having a program is going to be very important. Missing any one of those, of the three legs, you're going to be not as effective as you can, and the return on your investment is going to be lacking a little bit. So considering all of these is going to be very important as you move forward. So today we're going to be touching on the science of infrared. So understanding thermography is kind of important, and so as this image just goes through its sequence, I just wanted to point out that infrared has some very interesting properties, very similar to visible light in a lot of regard, but it's also different. In this particular example, we showed an image of three people thermally. What was going on is the image, there's both a visible and an infrared image taken. The infrared image is a reflection off of the glass where the visible light goes through the glass. So it's just one of the very early thought considerations when you're doing infrared, is that there's some interesting technology that goes into it, interesting thought, and you just need to apply that as you're trying to use your camera so you can most affect proper image, proper interpretation of exactly what you're looking at. So unlike glass, the lens of your camera, many are made out of germanium, will transmit infrared radiation through the material. The lens of the camera is probably one of the single most expensive components on your camera. It can be easily scratched. There is a coating on there that only allows a certain wavelength through it, specifically about 8 to 14 micron. Allowing the quality of the image to be as good as it can through the material. Being expensive, you don't want to be rubbing or scratching that with any regularity at all. Replacement is fairly expensive, and so anyway, protecting that with either the lens cover and certainly not exposing it to harsh chemicals or abrasive materials is going to be very important. So a little bit about infrared. It's part of the electromagnetic spectrum. it's either above or below visible light. Visible light ends at 0.75 micron. A couple interesting things. Infrared radiation can't be seen, but it can be felt by the skin. So a bonfire, as an example, is something where we would be seeing the visible light, but what we sense, what we feel, is that infrared radiation. Every object around us above absolute zero emits infrared radiation. The intensity of that is dependent on how warm something is, how hot it is, and other anomalies about the properties of the material itself. One of the key ingredients in that is the term emissivity. It's the reflective properties of the material. And when you go through a thermography infrared class, that is one of the key subjects that's talked about at some length, because understanding that's going to be very important in the interpretation and analysis of your image. One of the areas that we're primarily concerned about in the building envelope is the long wave, typically between 8 and 14, or in this case 8 to 15 micron. It's the wavelengths that are most appropriate for imagery in the building envelope area. So what does a thermal imager do? Well, it displays a thermal pattern of radiated energy from the surface. One area that's often confused is that when you're looking at infrared cameras, somebody might say that it's capturing temperature data. Well, in fact, an infrared camera captures the thermal radiation that's emitted from the surface of an object, whether it's, in this case, the walls, the ceiling, the doors, etc. And the camera is then turning that into a pattern of temperature, making it look like a digital image, giving you a representation of the radiated energy from that surface. The visual verification visually shows you where potential problems might be, and it can be used as a before or after image. So after an area of insulation is fixed, you could then have an after image showing that that pattern has changed and that you fixed your problems. Also, in the building science, where you're actually doing work, it can potentially reduce the liability that you would have by doing this kind of work for others. It improves your efficiency, getting work done faster and more reliably, and it certainly adds a revenue stream if you're considering it for adding it to your business, whatever that business might be. So also a consideration is what a thermal imager does not do. Well, it doesn't see through walls or materials. The only exceptions are that infrared will go through very thin plastics. It, of course, goes through the atmosphere, and it goes through the lens of your camera. Also, if you're using infrared windows, that's the same type of material that the lens of your camera is made of, so it'll go through that as well. But with those few exceptions, infrared does not go through anything. A camera will allow us to distinguish moisture in our thermal image, as you can see in the image that popped up in the lower right-hand corner. It does give us the opportunity to measure temperature based on the radiation that's emitted from the surface. And it gives us an answer that needs no interpretation. Well, it's not true. And a thermal image is a perfect image that's worth 1,000 words. In many cases, having some very descriptive dialogue that goes along with an image is extremely important. Well, getting to a little history, Sir William Herschel, back in the 1800s, just made a couple discoveries. One, don't stare at the sun, but two, that the different colors of the spectrum contain different levels of heat. So he devised a couple experiments, and one in particular was that he directed sunlight through a glass prism, and he carefully measured the temperatures of the rainbow of colors coming from the prism, and discovered that as he moved from the cooler colors to the warmer colors, that those temperatures continue to increase. And ultimately he discovered that above the red there was a colorific ray, or what we're now calling infrared radiation, which was even warmer. So it allowed us to, from his experiments, to make some very interesting leap forwards in our discovery of that infrared radiation. Infrared is similar to visible light. It goes the speed of light, and it goes in a straight line, and it can be reflected or it can be absorbed. Now, thermal imaging, one of the key benefits to it is that it's non-contact detection. It allows us to measure the emitted radiation from a surface without any contact of that surface. So there's no destructive investigations or anything else. Obviously with certain limitations, but it's a great way of getting a good thermal image, a good data from a source. What we see on the left-hand side is the ceiling and wall where they join. The image on the right, thermally, what we're seeing are the nails and the screws holding the sheetrock onto the wall, and we're seeing some anomaly there at the joint area. This area is a roof support beam that's going across the ceiling, just giving us an idea that there's some thermal issues going on, or some thermal differences behind the surface. Where can we use thermal imaging? Well, they're easy to expect. Building envelope. We can look at use it for building commissioning, for energy auditing, weatherization, home inspections. We can use it for electrical equipment, whether it's in the house or for industrial applications. Electronic circuits, mechanical equipment like HVAC. Also, another key is the industrial low-slope roof, typically flat roofs on top of buildings. It does not work well for imagery of the sloped roofs on homes. A couple of quick comments. The image in the upper left-hand corner is just heated electrical tape below the tile floor. We're just validating that the system is working. The image in the lower left, this wispy pattern that we're seeing can be due to either two effects. One, positive air pressure due to wind on the opposite side of the wall, or you could see this pattern if you're using a blower door, decreasing the pressure on the inside of the house, drawing that, in this case, cold air in. That would be a cold, drafty feel that you might sense in that room, but thermally you can see the cold air blowing across the wall in that direction. Also used in human health, becoming more popular in that particular area, and of course equestrian or other animal health. Common sources of air leakage. From the DOE, just talking about areas that we would focus our attention on air leaks. Those areas around the floors, walls, and ceilings, around fireplaces as an example, or even plumbing penetrations through the walls. Misaligned doors and windows is another key area for finding air infiltration or exfiltration from a home. So what are we looking for? Well, of course, air infiltration. That's tied with a lot of energy use or creature comfort within the house. We're also looking for insulation or installation issues, knowing whether it's installed properly or whether it's there at all. And of course, we have the opportunity to discover moisture issues. And of course, with the infrared camera, it's thermal sensitivity, even discovering some construction problems. Where do we look? Well, indoors, we're looking at walls, floors, ceilings, ductwork. On the exterior part, we can look for thermal bridging. We're looking for door and window misalignment, construction joint problems, and of course, the roofs. Looking at HVAC systems, the ductwork, the exterior HVAC system, looking at the condenser, the air exchange unit, etc. And of course, looking at any electrical or mechanical systems within the house or some manufacturing facilities. We're also, with an infrared camera, looking at all of the area that's conditioned space, comparing it with the unconditioned space outside our controlled area. We're looking at the doors and windows, at areas where you have joints between the walls and the ceiling, crawl spaces, etc. So some of the benefits, well, it's extremely sensitive to various problems within the house. An infrared camera can scan large areas quickly, doing a good job of scanning exterior of the home or interior of the home. It's going to identify specific locations. Of course, once we find that, we can get moving a little closer and we can get a better idea of exactly what's going on. And it may, in fact, require some additional tools. Anything from moisture meters to looking at the humidity and temperature of the environment, etc. Another key to thermography, as I've mentioned, is its non-contact. Allows us to see problems without actually making contact with surfaces. And of course, one of the key paybacks is detecting problems before there's significant damage. Being able to analyze what's actually going on and fixing those things, and then validating that before significant problems occur. So just talking about the modes of heat transfer, when you start using an infrared camera, this is one of those key areas that you need to understand. In the area of conduction on the left-hand side, consider T1 as your outdoor air temperature, T2 is the indoor air temperature. The second law of thermodynamics states that heat always moves from hot to cold, so if it's warmer outside, we're going to see the heat moving from outdoors to indoors. And the pattern that we're going to see on the inside with our camera is going to give us an indication of what's going on based on how that heat moves through various materials within the wall. Of course, different between a 2x4 and a 2x6, and certainly different between different types of insulation. So understanding the construction, knowing different construction materials is going to be very important in the interpretation of exactly what's going on. Convection, another mode of heat transfer, is typically or is through fluids and gases. This is an area where it makes it a little bit tricky when we have forced convection. In other words, we're looking at something and the HVAC system turns on and we have this movement of air. It can thermally change the pattern that we're actually looking at. So just being aware of these technologies, these modes of heat transfer are going to be important in interpreting our images. Now, radiation is a little different than the other two. What this is basically telling us is that it's part of the electromagnetic wave, and we're seeing the radiated energy from the surface. We need to have convective and conductive processes going on behind the surface. As that heat migrates through, it hits the surface and then is radiated into the surface, and that is what the camera sees. So as sensitive as our cameras are these days, we sometimes get that feel that we're seeing beyond the surface, but in fact we're not. We're only seeing that the changes through conduction and convection behind the surface, and once it's radiated, the pattern that we see is what is going to be interpreted and displayed on our camera screen. This just happens to be an image of the backside of my home. And I'm showing it for a couple of reasons. One is that this wall faces west. The sun just set about 20 minutes ago. We're still in twilight. The warm areas in the bottom down in here are 1-foot concrete block, core filled. So they have a lot of thermal capacitance. So during the day they warmed up, they're going to radiate heat for quite some time. The wall is a 2x4 fiberglass installation. It's a vinyl siding. It doesn't have very much capacitance to store energy, but we are seeing the 2x4 studs that are now radiating a little of that energy out as being warmer in the image, where the areas of fiberglass in between the studs are displaying something a little bit cooler than those studs. A couple points. One is just the eave is blocking the heat that's radiating up. It's blocking it to get from getting to the sky, so we're seeing a little elevated temperature here, and also the heat that's emanating from the surface is also warming up the siding right in an area like that and then right in this area. Of course, the saturated area up in the upper right-hand corner is a halogen outdoor light. It's supposed to be hot. If we were displaying that as red, much of the other detail would disappear in our image. That's part of the level and span that's also taught in a level 1 class to understand how to present an image as effectively as possible. Here's just another image, often very typical, looking at a ceiling here and the wall here, showing a little bit of thermal pattern where the studs are and the nails are. But this area that we're looking where the ceiling and the wall join, it's a very typical pattern because of the movement, the conductive or the convective radiation within the room, showing this blue line. Again, very, very typical of an image. I'll show you some examples of other problems as we move through today. So thermal considerations, we always talk about the thermal gradients existing between outdoors and indoors. Some of those are significant influences to the pattern that we're going to see. And again, as I mentioned, conduction, the movement through the solids, through the studs, and through the sheetrock and things like that. The ability for different materials, thermal capacitance, to store energy. We also deal with convection, the movement through air and through liquids and gases. And of course, the load on the system. I've got an image where the sun can create extremely significant thermal loading on a wall structure, giving it a very different thermal appearance. And of course, emissivity, the reflective properties of materials, giving it kind of an unusual pattern. And what I would show here is this is just a door, very cold outside. We have some cold air infiltration in this area, the blue, because of a seal around the door. But here we show another area of a little bit warming, a warm area, and that is due to the emissivity. This is an aluminum kick panel on the bottom of the door, so it is really reflecting the background temperature, the warmer area that we're seeing in areas like that. So it's making the image just a little tricky to decipher, but if you know what it is that you're looking at and you understand the basics of thermography, it makes it a pretty easy image to diagnose. But again, it does take some words to describe exactly what's going on. And of course, state changes on the surface. You know, as sun is on the surface and then leaves that surface. You know, as it moves to a different wall surface on the west side of the house versus the east. So we have these changes of state within the environment, the materials that we're actually looking at. Of course, the wind effect plays an important role in being able to diagnose exactly what's going on. The wind has a significant effect on the radiated energy coming from the surface. And of course, you have to deal with the angles. Too steep of an angle is going to cause some additional problems. Again, these are all things that you learn in an effective level 1 class. Of course, understanding your surroundings is important as well. Again, just looking at that radiated energy from the surface, again, just a wall, the typical handprint, just showing that when I touch the wall, the heat from my wall convectively went into that surface. I removed my hand, and now it's radiating back out towards the camera. Here is a case, a home that I was looking at. They had water infiltration. These areas of cooler area are moisture beyond the sheetrock, and of course that cooling effect is creating a cool appearance on the surface of the sheetrock, which the camera sees very well. I was mentioning thermal loading. We have an east wall over here, our south wall on this side, two very distinct patterns. I would just draw your attention to the sun. We see the sun on the south side, and the east wall is in the shadows, showing a different thermal pattern. So when you are in a situation like this, you just want to be aware of where the sun is, actually what's going on with the environment around it, so that you make a good diagnosis of whatever that problem might be. So there are some basic conditions in order to perform an effective scan. One, you need a direct view of whatever it is that you're looking at. Infrared, like I said earlier, goes in a straight line at the speed of light. You need to be looking at the surface directly and be as perpendicular, that's a good thermal practice, as you possibly can. But consistency is important as well. And just understanding your environmental conditions, again, the wind, where's the sun, et cetera, et cetera. And make a plan and follow it. If you're going to be doing a home scan, a good practice is always turning to the right. So you follow some normal common pattern so that you don't miss things and you do an effective job of analyzing the environment or the area that you're actually scanning. Just draw your to the upper right hand corner an image that I just happened to take at a trade show. This is showing the heat pattern from an infrared heater that's actually pointed down on the carpet. I thought it was just kind of an interesting thing, and having a camera will travel, so to speak. The image on the lower right is a house that's currently burning. Although these aren't visible flames, it's just the heat pattern under the surface that we're actually seeing. Of course, there's some visible smoke there, and these are the firefighters down here in the lower part of the image. So the types of measurements. Most imagery in the home environment are going to be just qualitative. We're just really dealing with the differences of what's going on in the thermal image. We don't care about absolute temperatures. We're just concerned about differences, areas where there's insulation or insulation is missing or not installed properly, or those areas that are wet. And we don't really care about absolute temperatures. This is one of the focuses in the Level 1 thermography class. When we get to quantitative, we're dealing with specific temperatures, trying to get and understand exactly what's going on. But a majority of the imagery is just qualitative. We're just really looking for abnormalities in our equipment or in our structures. So what do you need to know? Well, you really need to understand how a building works, the materials that go into it, understanding the different types of insulation, the different types of wood structures. You should understand the basics of heat transfer, so you understand that movement, so that when you're interpreting your image, that you'll have a good explanation of exactly what's going on. And a key, the other part of one of the legs of the stool is just your understanding your camera operation. Knowing how it works is going to be very, very important. Organization and using different standards, RESNET, the building BPI, also continuing your training and education and getting a good Level 1 class and get some certification through that. A successful audit, understanding the conditions for an audit. If you're doing air leaks, RESNET suggests that delta T of at least 3 degrees. And what that means is just a difference of temperature between outdoors and indoors. If you think about the fact that we're trying to measure a difference, if the outside temperature and the inside temperature were the same, you just would not see a thermal difference at all. And if it gets too small, it's just going to make it very difficult. So in air leakage, we want at least a 3 degree, if not more. And when you're doing insulation, RESNET suggests at least an 18 degree delta difference. If you have a very good camera, you can get by with less than that, but if it gets too small, you, again, just not see any difference, or you won't be able to interpret those problems very effectively at all. I would just draw your attention to the upper right-hand image. This is an image of a family room indicating that there's a thermal anomaly going on here. The conditions were it was summer outside, very warm, air conditioned on the inside. This warm pattern is just giving an indication that there's some anomaly going on. There's definitely insulation there. It's just not installed properly. So some of the things in the form of interpretation is knowing that what those patterns are and how to interpret it. So you don't tell somebody that there's no insulation there, and in fact when they go up to look, there is. Now all of a sudden, you know, your reputation may be tainted just a little bit. So just be careful in the interpretation side. And of course remembering the solar loading and the wind issues for masking problem. Another key point is learning to focus your camera. Extremely important to get good data, not only in presenting it to others, but interpreting it yourself. So inspecting with IR, we would like to have a stable home if possible. Suggested to turn off the HVAC system before you start your scan to reduce the amount of forced convection that you might encounter. That also helps to stabilize the temperature. You want to perform an effective visual inspection of the envelope and work systematically. Part of the visual inspection is that when you do see an anomaly, you'll remember potentially the fact that you saw something that, well, could cause you some issues when you're trying to do that thermal scan. And images are going to be hot and cold depending on the climates. Again, the left-hand image showing cold air infiltration due to either the installation of the door, it's not installed quite properly, or the seal around the door has degraded over time. The left image is just showing an electrical circuit that has some kind of a short, and of course that short is causing heat to increase the temperature of the conduit behind the wall, giving you an elevated temperature there. You want to inspect from both inside and outside. It's important to be able to correlate things that you might see outside with inside, so that you're doing an effective job of reporting proper information. And you want to potentially validate with other tools, determine that you actually do have air infiltration versus moisture, or the other way around. It's important to giving the correct diagnosis for the problem. So inspecting, building inspection or energy auditing. Couple images that are showing up just as an example. The upper left-hand image just showing some moisture problems. This happened to be an image that I was able to capture during the day. I'm standing on a taller building, and the building that I'm looking at, the roof that I'm looking at, is actually in the shade of where I'm standing. Once it was in the shade, that the energy that was in the roof structure is emitted to the sky. Those areas where there's moisture, they have thermal capacitance, so that warm water that's underneath the membrane is now showing up as warm spots. The upper right-hand image, Again, there's insulation in the wall. It's just not quite installed properly. It's folded up a little bit in this area here, showing the what appears to be a pretty good anomaly. There's insulation there again. Again, just not installed properly. The center image, moisture behind the sheetrock. In fact, these lighter images, spots right in here are my fingerprints touching the wall to check the integrity of the sheetrock. What was wrong here is the seal around the window had broken because the window was not installed properly. It was rubbing against it and actually wore the rubber seal gasket right off the window. The left-hand image is a mud jacking case where they were going to drill a hole, and of course Murphy would be there and they would drill a hole right through one of the tubes. Well, we just had them turn the system on. We marked out the floor, and now the instructions, you can drill 1,000 holes, just stay 2 inches away from one of the lines to effectively facilitate the mud jacking without damaging the heat coils. And the lower right-hand image, here is the rough opening for the window, and you can see that that has good integrity. It looks like the insulation was done well. What we're seeing is cool air blowing in, cold air in fact, blowing in. Actually the glazing around the glass had degraded, and this would be that cold, drafty feel that you would feel in a room. The next one, just a moisture underneath the roof. Happened to be a Target store here in Minnesota. Whoops, the same duplicate image. Here we have a cold air blowing in underneath the door. The lower right-hand corner, the attic access, cold air infiltration. This was a view during a blower door test. So we decreased the pressure in the room. Cold air is now blowing in. To help facilitate and fix that, probably just a rubber gasket around that door there. Here is an image taken with an infrared camera showing only the moisture. So what we selected here was just showing us the dew point, or what's below room temperature, and everything else is invisible light. Here was a case using a blower door. This is a home where we see some cold air infiltration being drawn in around the area where the ceiling and the wall meet. There was a Ronald McDonald House in Minnesota where we have some cold air infiltration behind the window frame in that particular image. Here was a application, again, wind on the north slope. This wall, the ceiling structure is facing north. There was about a 10-mile-an-hour wind. We're seeing that positive air pressure out there actually forcing cold air in around cracks and crevices. Now, here is an interesting image. It can be misinterpreted. There is a lot of thermal loading on this south wall structure. You can see the sun outdoors looking through, visually through the window. This solar loading is going to give you a pattern like that you're seeing here on the ceiling, indicating that, well, there could be a little bit of an installation problem, but the fact that there's so much loading out there that the misinterpretation could be made of that pretty easy. This was a home in St. Paul, just giving you an idea. The upper second floor was completely remodeled, and this was taken about a year and a half ago. They had about 400 pounds of ice hanging off of the eaves. There were 4 gables on each end of the house, north, east, south, and west. And what happened was that they did a good job of insulating the ceiling and the wall structure. But what they didn't do is seal right above the wall here, and so we had this heat pattern on each of the gables on all sides. The snow accumulating out here would melt and come down here and refreeze, causing the problem. So they had to go in and re-insulate that particular area. Here we're just seeing, it could be a very typical, if you have a cold exterior. This is probably the problem with installation of the insulation. Here's just a junction box near the ceiling of the wall. Very difficult area, and an area that the contractors typically don't spend a lot of time doing a good job of repacking insulation right around that stud area that would be there. So it's kind of an area that would be often typical of an older home. Here was a hospital that had just had their north wall re-insulated, and I was just out taking some images, and I reported back that it's not that there's not insulation there, it just like they didn't do as good of a job as they potentially could have. Again, we have warm air infiltration. This is during a blower door test, just indicating that in the wintertime it could be potentially very cold air, but it's just the sealing around the sealing that they did around the areas where they've got some beams and things like that. Here was a home that had some very significant ice damage issues going on. Sloped roof. We're seeing an insulation problem in these areas where it's blue. And of course, when we have fancy construction, which you can see in this particular pattern here, it's a little bit more difficult and a little bit more tedious to do good installation of insulation. So you're going to get these cold areas around all of the angled boards and studs that are put into the wall. From a moisture standpoint, infrared can easily see the cooling effect of evaporative moisture, even below surfaces. Because of that evaporative effect, it could be as low as a degree different than the ambient. Areas will look dry, but below it you are seeing that moisture. Of course, here's an area we're seeing moisture in sheetrock right above the baseboard, and of course at and below the baseboard, and even spots in the carpeting down here. Here was a expensive condominium in Chicago. The surface was made of limestone. It was treated to be non-absorbent in moisture. Of course, these cool areas are all significant areas of moisture infiltration into the surface, causing significant damage on the inside. This facility is going to have to completely reface their buildings. So where's thermography used? Many applications. Of course, today we're mostly focusing on that building diagnostics, the building envelope, whether it's water restoration, remediation, could be roofs, but in the electrical, we're looking at motors and bearings, electrical panels, switch gear. It's almost endless. It's a phenomenal technology for helping facilitate diagnosing problems in a lot of different areas. In the electrical applications, just looking at some various pieces of equipment. Of course, the infrared camera is looking at that emitted radiation, and so circuits where we have a loose connection, as an example, elevated temperature on the wire, we can compare it with this wire and give ourselves a delta of understanding what's going on. Again, a connection issue here. And again, at this substation, we can see a significant change of temperature due to some kind of a connection problem. Whether it's convectively cooled transformers, low voltage relays as an example. This one here in the upper right-hand corner is just due to vibration, a connection issue. And again, various components just showing different aspects, but an infrared camera is extremely effective in diagnosing these particular problems. On the electromechanical side, everything from looking at some pillow bearings. In this particular case, and this one was fun, we actually were adding some lubricant to see if we could modify the temperature because it was just a lubrication problem. And in fact, we brought it right back down to the ambient temperature, the temperature of a unit right next to it. Whoops, sorry. I'm having problems with my, oops, sorry. Upper right hand corner is just a misaligned belt. We have belt problems. Well, I've lost my pen, sorry. We have in the upper right-hand corner a cement kiln, breakdown of insulation, a level of concrete powder in the tank on the upper right-hand corner. And a couple other images, a deep well drill head looking at the cooling process from the welding pattern that's developed there. Common mistakes in thermography, and focus is probably one of the most common. It's something that has to be mastered when you start to use infrared. One thing that you can't fix with an image. Because of the digital technology, most information that you capture with an infrared camera can be modified and stuff in software, but focus can't be changed. Assuming that the temperature presented from the imager is correct. When you start learning about thermography, you're going to realize that there is a lot of different things that we're seeing with an infrared camera, and assuming temperatures based on what the camera tells you is a significant no-no, so to speak. Interpreting moisture from just cold air infiltration. In some cases, they can look the same. That's where having other tools in your trade is extremely important. Not accounting for the environmental concerns, you know, the sun, the wind, the temperature differences between outdoors and indoors. And of course, assuming temperatures, that second major bullet above, is part of not accounting for those reflective properties of the materials being viewed. That's where you'll get some temperature anomalies, or what appear to be significant temperature anomalies, which aren't significant at all when it comes to the actual application of what you're trying to evaluate. And just misstating the problems observed. Telling somebody that there's something in the image that's really not there. So these are all things that you learn in a good training course. And not setting the stage to capture the best image, you know, framing, understanding steady state versus transient, and understanding construction and the construction materials that go into it. In choosing an imager, first of all, just understand the application that you want, whether it's the building envelope, industrial, either electrical, mechanical, high temperature. All of these different applications might require selecting a different camera. So just understanding it's going to be very important. Argumentally, the building envelope, typically we need the most thermal sensitivity because we're dealing with things that have less temperature difference between, say, outdoors to indoors. Of course, RESNET standards suggest 100 millikelvin. When you're looking at a camera for the building envelope, you want to exceed that, either less than, but no more than 100 millikelvin. The lower the better, of course. Of course, imagers are priced all over. Understanding the use, the need that you have for the camera, and compare that back to the price. Just going with the least expensive imager might not be the best thing from a return on your investment because of the days and the times that you can actually use it. A more thermally sensitive camera is going to be a little bit higher in price, but the days that you can use it are going to increase. So just watch that very carefully as you're trying to go through the selection. Thermal resolution. What is it you're looking at? How detailed do I need to have the camera? Thermal resolution is just basically the number of pixels. It's very similar to looking at a 5 megapixel versus a 8 megapixel camera in the digital world when you're going to, say, Best Buy to look for a digital camera. Understanding the resolution of your thermal imager is going to be important as well. So be concerned about the detector size. They range all over the board from typically 120 by 120 to 640 by 480. Of course, the more pixels, the more expensive the camera will be. So what does all this mean? Well, depending on the application. Often, distance to target versus your target size are going to be important. If you're going to be viewing things at a greater distance, then you want to have more resolution. Typically, if most of your images are going to be inside of a house at the 5 to 15 feet away from the target, almost any camera will work in those particular applications. But just understand that the further away you get, the more resolution you're going to want with the camera. So just as an example, just looking at two different types of images. If you're at a greater distance, having a camera with more resolution is going to be important. And of course, ultimately it comes down to your budget. So a few things about infrared. We talk about the distance to our target. This image in the lower right-hand corner showing a bigger building at a further distance. We're not seeing very much detail there. Thermally, we can see thermal patterns, but if there was any anomaly there, areas around windows where there's air infiltration, we will not see it in this particular application with this camera. As we get closer to our applications, in this particular case just showing a red showing an anomaly in this power line. We can't necessarily measure the distance because we don't have a camera capable, but I can see that there's a problem. This is what we call our spatial resolution. And of course, as we get closer, we now can see specific anomalies. So in the right-hand image, we can see some nice thermal detail on the outside of the wall. The left image is just showing the moon in this particular application. So again, choosing an imager, some key things to think about. Visual camera on board. Often thermographers will carry even a second digital camera. But keeping track of the two images, one thing that I would share with you is if you do have two different cameras, set the date and time stamps together similar on both cameras so that both of the calendars and the timer are the same. When you download the images into a folder, put them in the same folder and sort by date and time, your two images will show up right together. Cameras are extremely easy to use these days. The manufacturers have done a great job of the touch and feel, the menu systems, etc. They have voice annotation. Sometimes they have laser pointers. And of course the displays, you have various options on those. Some even have compasses or your GPS location indicators on them. Continuing, don't forget the software. Software is important. When you're out taking images, connecting you to your customers is how you present those images. So do a little investigation into the software package that works for you. That makes it easy to go from image taking to report writing. And of course, just know your budget. Include some plans for training. It's important. As you've seen in some cases here that sometimes imagery can be rather difficult and it's a challenge. But plan for training and you'll do a good job. Be careful not chasing specific features offered by a manufacturer. Go to the tried and true things with a camera. Looking at those odd things that they put in the camera. You just end up not using them. Also, when you're investigating, talk to reputable people in the industry to get a good idea of those types of things that you're going to actually use when you're out in the field. Talk to Bill at TruTech Tools. Another area it's level and span, interpreting the image. In this particular case, just like the back of the home that you saw earlier, in this particular case we have a halogen light that's warm. It really kind of washes out that area of interest that we have. Of course, the area of interest is the insulation in the ceiling. We've saturated the light, giving us a much better image on the right. So having control of your level and span is extremely important. So narrowing the span gives us that best image. So just some guidelines from RESNET. I've mentioned them a couple times here. Resolution is just the noise equivalent temperature difference. You're going to see that in the spec listed as the LTD. It's a important spec to consider when you're thinking about doing a building envelope. It is not quite as important if you're going to be doing electrical and mechanical scans in the industrial marketplace. The spectral range, again, falls between 2 and 15 micron. For building envelope, the key is generally listed as 8 to 12 or 8 to 14 micron. Of course, field of view is going to be important. Typically, the cameras, the standard lens that comes with a camera is generally very capable of doing what you need to do for your building envelope. If you're going to be doing distances, then you may want to consider the telephoto lens. And if you're doing a lot of work in very tight, close areas, then maybe the wide-angle lens may be important to consider. Other guidelines, recording the image, understanding the format that are capable of being saved as. Most cameras record images in their format that's for the manufacturer and can be used in their software. Typically, they're not shareable between different manufacturers. Understanding the instantaneous field of view of your camera. How close do I have to be to actually get the detail that I want in my area of interest? So it's just to be aware of it, and those are great questions to ask. So in the reality, the imager can be the answer to your question. Thermal cameras are phenomenal tools. They're easy to use, point, simple to focus as you practice and learn how to do that. They will make you more effective, more efficient when you're trying to do your work, and of course, time is money. Finding those anomalies more quickly, solving those problems are going to be important. And of course, consider training. You will find thermal problems, you'll discover and report them quicker, being able to validate those repairs and actually verify installation, new commissioning of buildings, and obviously to verify that the repairs have been done effectively. So an infrared camera is effective, and you will see an ROI, a return on your investment, if it's used properly. So at this point, open it up to any questions. Type them in under the side there, and Bill can read those off.
Well, so far I've seen no questions come up through the course of the presentation. We'll continue on for a couple more minutes here and see if any others do rise to the surface. While we're waiting, if you're thinking of questions out there, I did want to mention that we will be having a level 1 training that John Pratten will be offering as part of the TruTech Expo. It's going to be a parallel track to the TruTech Expo, which we hold in Brecksville, Ohio. It'll be the dates shown on the screen now, July 16th through 19th. It's a level 1 training. We'll be doing it in kind of a little different way. If you wish to get the level 1 certification, there'll be one price. And if you just want the training and you're not so interested in having necessarily the certificate, you can get it for a less expensive price. So if you go to the little website noted in the corner there, that's www.bit.ly/TTTexpo. That will take you to a registration page, or you can just give us a call at 888-224-3437 for any kind of updates or questions you might have for that. So still got a lot of people hanging around here. Any questions on your mind, please come forward with them. In May, we're going to be working on a series of programs with or webinars with John that will cover brand-specific camera training from all three the major thermal imager brands that we carry, which are Fluke, Testo, and FLIR. So we'll be looking forward to that. John's working on the materials for those at this point, so you can be looking forward to seeing some information there. If you want to hit that last slide, John. Yeah. Here's the contact info if you want to jot anything down. The slides will be posted shortly, as well as a recorded session, this recorded session you're listening to right now. We also do some more technical videos on our YouTube channel, which is posted there, youtube.com/user/Jim Bergman with 2 N's and the number 3. John's contact info he's offered there is email address as well as his cell phone. And then there's contact info for myself, Jim, my co-owner, TruTech, and Eric, our sales manager. So there's a number of different ways for you to get in touch with us. You could always just come back to the website or give us a call on our toll-free number. We'd be happy to help you out either in selecting a camera or helping to learn how to use the camera that you do have. Okay, I haven't seen any more questions pop up, so I think we're going to wrap up here today. Oh, wait. Did I see a question? Okay. Someone just missed what time of day we were offering this, and we will be offering it again next month. Just look back on our webinar page for that. Check back there, TruTechTools.com/webinars, and you'll find out when we haven't scheduled it yet, but we'll be offering this again next month. And the recorded session, everyone who attended here today will receive an email with the listing for the recorded session, so you can listen to that too. Okay, no other questions. I want to thank everyone for attending and thank John for presenting. And we look forward to seeing you back again, and give us a call, and we'll see how we can help you out. Take care, everyone.